What's up, guys? Today we're going to be doing some more SAT practice. Today's topic, SAT math constants questions. Let's get right into the video.
So the way I like to break these down is look at what's given to you. So you're given a function g of x is x plus 14 times t minus x. And then, so from that info, that doesn't tell us a whole lot. And then they just say y is the same as g of x. It's pretty basic. But then they give us this point, 24 comma 0. That's some key info. And whenever we're given a point like this on these like constant questions, you always want to plug it in and then see what you can do. So let's do that. So we know that x is going to be 24 and that y is going to be 0. So we plug that info in. Let's do that. So g of x is the same as y. They tell us that, but that's just common sense as well. So we put in a 0 for y, and then we put in a 24 for x, and then again another 24 for x. Okay, and then now this is a pretty standard equation, and we can just solve for t. So let's do that. So that's going to be 24 plus 14. It's going to be 38, and then times t minus 24. We'll just leave it like that for now. So you could distribute the 38 in and then solve for t, like a linear equation. But here's a little shortcut you can do. When you have like a number multiplying a like parentheses like this, you can just divide it out. Like you can do the inverse operation. So you can divide this 38 out on both sides. It'll cancel out here. 0 divided by 38 is still 0. So then you're left with t minus 24 equals 0. Add the 24 over, then you're left with t equals 24. So if we know that t is 24 now, then what we can do is we can plug that in for the constant. We know what the constant is. That's generally what you're going to end up doing. You're going to find that constant and then use that constant to answer what they want. So let's do that. We got g of x equals x plus 14 times t minus, or sorry, 24 minus x, because we're going to plug the t in. So then now we want to find g of 0. So that just means we plug in a 0 for x. So that's going to be 14, because x is 0, times 24 minus 0 is 24. You multiply that out. I'll just show how to do that over here real quick. This is non-calculator, so you're going to have to remember how to multiply these numbers. So if you get that. So then our answer is going to be 336. So the key to these is really just find the constant using what's given, and then once you find that constant, then just use your head, figure out what they're asking. In this case, it's just g of 0, so we just plug in a 0 for x. And yeah, these questions can be a little bit intimidating, especially with the time constraints of the SAT. But if you use these strategies, they're not too bad. Okay, so very next question on this same exam is another constant question, but this one's a little different. So we're given an equation. This is an equation of a circle. It tells that. That's also just the format of an equation of a circle. If you've taken geometry already, you should be familiar with this. So yeah, we know it's a circle, and then they tell us that A comma B lies on the circle. So what that means is that we're going to have some circle, and then we're going to have some point called A comma B. It could be anywhere on the circle, really. It's just some hypothetical point, and we're just we have to find if one of these values can be A, because it says possible values of A. So what we have to do really is this is a plug and chug question if you think about it. So because they don't really give us too much info other than we have point A comma B, it's on the circle, and then these are potential values of A, which are x values. That's another way, because A is the x point. So really we're just plugging this in for x, and then we're seeing if that makes sense. So from this point on, it's actually really easy. You just have to think about it for 2 seconds. So when I plug in, let's say like 11 for x, that's going to be 11 plus 4 is 15 squared. That's like, I believe it's 225. And then plus whatever, we know that both of these values, they're squared, so that means that they're always going to be positive, right? So that means whatever value we get for this section right here has to be lower than 121 because the y part of the equation is always going to increase the value. So we have to plug in each value and then go, okay, does that make sense in this context? So it has to be lower than 121. That's like the connection you have to make here. If you understand that, the question becomes pretty easy. So you do negative 16 for a plus 4 squared. I'll write that out. That's going to be negative 12 squared, which is 144. So then no matter whatever hypothetical value of y we pick, like even if we picked like negative something, like negative 1 minus 19, negative 20, well, when you square it negative, it becomes positive. Or even if you picked 19 as y, you made it 0, it's the lowest possible value it could be, you're still going to have a number that is, like it's still impossible to get to 121. So x plus 4 squared, like I said, it needs to be lower than 121 to give this the opportunity to do so. So then so that's not going to be the answer. And then negative 14 plus 4 squared, that's going to be negative 10 squared, which is 100. So that's going to be our answer because that's less than 121. And then if you just go through the remaining ones, you'll see that those clearly cannot be it. I mean, if you just do it in your head, you'll see that like 15 squared and then 19 and then 19 plus 4, 23 squared. That's not going to be it. So this one may seem confusing at first, but this is just a simple plug and chug question. You just have to determine if it makes sense that those could be the number. So yeah, that's a second type of constant question you may see on the SAT. Okay, so here's another example you might see. It's another quadratic type of question. We got that here. And then they tell us that g of 7 minus w is 0, so that's key info. And then we want to find all possible values of w. So just like before, you want to kind of synthesize the info that's given to you. We have this quadratic. We know we can solve quadratics for 0, find where it's equal to 0. So, and then they tell us that this is 0, so that's some key info to keep in mind. And then we want to find all possible values of w. So what you have to realize here is that there's going to be a couple possible values of w, and that's going to occur at the zeros of this function. And then when we find that, then we can just set 7 minus w equal to whatever, x value makes that function 0, and then we can work backwards from there. So we got to find where g of x is equal to 0. So this is pretty simple because if you notice, this is a factored quadratic, right? I'm going to rewrite the function out just so you can see. So this is already factored, so that makes our life easier. If you've taken like algebra already, you should know that to solve a quadratic when it's already factored, you just break each factor up and then set them equal to 0. So we already know x is going to equal 0 because it's just 0. When you set it equal to 0, and then you solve for 0 here, you get x equals 2. You do that here, you get x equals negative 6. So we got the zeros of the quadratic. Now we just have to find, so we know that g of 7 minus w equals 0. So basically it's g of 7 minus w. 7 minus w has to be 0, 2, and negative 6. So let's do that. So 7 minus w equals 0. W equals 7. So if you don't understand what I did here, basically I found that w is 7, and then if I plug that w in, like here, I'll write that up here, you'll get 7. G of 7 minus 7 is g of 0. We know g of 0 is 0. That's why w is 7. Same thing here, 7 minus w equals 2. W is going to be 5, because if I plug that in, g of 7 minus 5, g of 2, you get the picture. And then 7 minus w is negative 6. W is going to be negative 13. And then they want the sum, or sorry, not negative 13, positive 13. They want the sum of all possible values of w. So our answer, I'm going to write that up here. It's going to be 7 plus 5 plus 13, which is equal to 25. All right, so those are the problems we're going to go over today. Um, I want to just do a quick recap over what we discussed to help you out on your SAT. Just a checklist on general strategy. So number one, I want you to just, when you get these questions, just plug in what's given to you. Like that'll help you get moving, and that's what we want. We don't want you to get like paralyzed and freak out with these questions and like read it over and over because that wastes valuable time. Um, yeah, so just plug it in, get started, and that'll get the ball rolling. And then from there, you can probably get the answer. So, and then two, yeah, you just think about once you plug it in, like what does this info mean in the context of the situation? So, like in some of the previous examples, like we were given points, right? So we were given like x, y coordinates. So we just plug those into the equation given, the function given, and then from there it became pretty clear how to get the answer. And then that's step three. Just once you get that additional context, just go ahead and solve it. Um, that's pretty much the general format on how you'll do these questions. I mean, every scenario is different. I'm definitely going to be coming out with more videos on these type of questions, but that's the general idea. If you can do this, if you do these three steps, you'll be able to get any of them. Some are more difficult than others. There might be a little trick you got to get, but that's the general idea. So I hope that wraps up this video. I hope this helps you get a better score on your next SAT. Question number 26 from that same practice test. For some of you that were following along, you might have noticed I didn't do that question. That's because that question is a little more involved, and I want to make that its own standalone video. So be on the lookout for that video. It's a constant question just like these. I hope you guys have a great day. If you want affordable tutoring, check out MVP Learners, link in the description. And other than that, have an awesome day.